G'day guys, it's Kelvin, coaching company in New Zealand. I get a lot of questions sent to me. It seems that I do exhibit some knowledge, and I'm going to run through today one of those questions. I'm sitting in my lounge, the light's not perfect, the sound's going to be pretty crappy, but the knowledge is going to be good. And it's a question that I see a lot. In time, I'm going to be doing more of these, possibly as a members feature, and there will be a charge because my time is precious, okay? And I'm going to work through some of the problems and make videos and provide free stuff on YouTube, so that stuff will stay free. But when you're involving my time is precious to me. I've only got so much of it, and so that's where I'm kind of heading. I charge for all the jobs that come into my workshop. Think about it like that. So I'm either doing a job on the internet for free or doing a paid job in the workshop. Which would you do? It's going to be the paid job. So let's get into this. Let's have a chat about the fault codes that this man has said and found, and the diagnosis process that I would go through to solve this problem. So the question today is from Joshua, and he said, hey man, I have a quick question. I've seen you look like a knowledgeable person on the LS400 page, so I thought I would ask if you're familiar with the codes. The codes he's listed are 41, 52, 55, and 71. And the problem being that I'm familiar with all of those codes, and I pretty much know them off the top of my head. He's gone on also to give me a little bit of the symptoms. For the 1993, with 175k, the car starts every single time amazingly and runs and has power just fine till it starts bogging and won't accelerate. I haven't done the ECU yet, however. Before I spend the money on that, I suppose, I was wondering if those codes could even be ECU related or not. Okay, and that's a fantastic question. Okay, what we're going to look at first is what are those codes? I'm pretty sure it's got it here. Codes. Code 41. And it's actually got an ability to put it into test mode, which a lot of guys don't know about. So even back in the OBD1 vehicles, there was a test mode. And this lays on under normal situations. And then in test mode, what if you're going to have a check light on or not? We'll touch on the test mode very soon. Code 41, the light would be on, and on number 2, check light would be on. Throttle position sensor. So that's code 41. We had a code 52 and 55. 52, knock sensor number 1. 55, knock sensor number 2. There's something possibly up with the knock sensors. 71, there's a 6 here, which is California vehicles only. And EGR system malfunction, California only. I know that those codes match with that list that I have there. So it also comes up on my scan tool. I've got a scan tool, OBD1 scan tool, that allows me to plug in and check that, and it brings those up. I can verify those codes. If I go over here, same deal. And this one's a little bit different. It has a little bit of an idea of where the codes or the faults might be. Code 41, throttle position sensor, signal, open or short, the sensor itself, or the signal circuit. We go down, we're going to have 52 and 55. It's knock sensor and knock sensor. 71 EGR. This one goes on to have a few other ones as well, okay, as far as other codes that the first list didn't have. But it matches with the first list that we have. Going on whether it's the ECU, a lot of people in a lot of forums, you go on and I say, you've got a fault, and they jump straight to it's the ECU. It's the wrong way to look at this problem. Toyota lists the ECU as the last thing, not the first thing. In this case, there's 3 separate faults. The ECU is displaying fault codes, so it shows that the ECU is working to some degree. And it would need 3 distinctively different areas of the ECU to fail to give those 3 different codes. 3 distinctively different areas of the ECU. The chances of that, there's a Lexus ECU, so it's possible. But you can't fix what you don't know. So right here, my logic tells me, let's look at the faults. Let's solve those faults. Let's fix the things that we do know. He also said that it stops accelerating. Now I have got somewhere here, failsafe. Let's just look at the diagnosis system. And this is a great bit of information telling us this might be for SC400, but the principles are very similar. And it tells us in here about, let's see, the normal mode, the diagnostic check as far as extracting the codes and how to get the codes, which is great. Diagnosis, inspection, test mode. And I have never seen anyone at all talk about that diagnostic check test mode on any of the forums. There's actually a whole lot of stuff in the DLC1 under the bonnet of manual testing that I know how to do as well, checking oxygen sensors and a whole lot of other stuff in test modes and signals that one day I'll get round to explaining as well. Just at this point, knowing that it does exist is probably enough. Sparking that curiosity. I don't know what I'm doing there. Fingers bumped it. Right, what is that one? Okay. What have I got in there? Oh, yeah. So I've got a matrix here. I've got a setup of problems against possible issues. Let's see if it actually has. Now, hesitation is poor. Hesitation is poor. Ignition circuit. Main oxygen sensor circuit. Water temp circuit. Intake air temp sensor circuit. Airflow circuit. Throttle position circuit. Hey, poor acceleration could be the throttle position circuit. Would we have a code for that? It actually doesn't bring up knock sensor circuit, but I wonder if we've got lax power. Engine stall, poor drivability. We've got knocking as a knock sensor. Poor fuel economy. Doesn't have just general poor. It's got poor drivability. It only brings up knocking. We'll discuss the faults of the knock sensor circuit in just a moment. So that's my matrix. Again, here's some of the possible faults. And what's actually happening in that ECU. I've got a code, find code 41. Now this is a bit tricky because they should be lined up beside each other. Okay, so code 41 There's the code showing throttle position sensor signal. Here are some possible diagnoses, and it's the threshold the ECU needs before it'll throw a fault code. So if it doesn't meet those conditions, it won't throw a fault code. And this is why you can have faults that the ECU doesn't throw a code for, because it doesn't meet the thresholds. We actually have a car here in New Zealand, one of the Commodores, the VE Commodore. You can unplug the airflow meter. It doesn't bring on a check light because the technicians didn't, or the engineers didn't program it into the ECU to bring that up as a fault. Go figure. So, throttle position sensor. Open or short detected in the throttle position sensor signal VTA1 for 0.5 of a second or more. So if it's not plugged in, there's a problem. If it's shorted, there's a problem, and the ECU should pick those up. Next one, IDL1 contact is on, and VTA1, which is the throttle position sensor, output exceeds 1.45 volts. So one of the things that I'm doing when I'm checking it with my scan tool, I'm plugging in and looking at the live data, is I'm checking that when IDL1, the idle switch, is at 0%, or is the idle switch is on, that the throttle position sensor is at 0. Because if you have your idle circuit on and your throttle 1.45 volts is probably like 15% open, then the ECU is going to throw that fault. I want them to be on, idle switch, and the throttle position sensor to be at 0. Because that's how it should be, because the throttle's closed. No, 0 throttle angle. And if I go down here, it's the fourth from the bottom. Should be this one. Possible faults. Open or short in the throttle position sensor circuit. So that's one of the first things I suggested. The sensor could be faulty, or the ECU could be faulty. How's that? So the ECU is in the list, but it's the last thing on the list. Let me see if I can find, there's our knock sensors. Okay, here's our knock sensor codes. Knock sensor 1 and knock sensor 2. Interesting, that too. Saying, and these will be the same for knock 1 and 2. And the threshold is the knock sensor signal is not output to the ECU, not input, sorry, to the ECU for 3 crank revolutions with the engine speed between 1600 and 5200 RPM. So if you drive below 1500 RPM, it may not bring up that fault code. And you need to remember that too for part of the knock sensor diagnosis. 71, there are some things in there. I don't know whether this car has got the EGR fitted. If the EGR has been removed, then you're possibly going to get a code, depending on which kind of EGR it has. It's the early one, possibly just a resistor is going to solve that problem. At this point in time, I'm going to focus on the throttle position sensor and the knock sensor. I'll talk about that again in a moment. Here we go. Possible reasons for the knock sensor: open or short circuit in knock sensor circuit. The knock sensor, looseness, it'll sleep with anyone. The sensors fail, and I'm seeing a lot of them fail. I do replace a lot of them now. I see a few that aren't done up properly, but generally all the plugs, they break off, or rats chewing the loom is pretty common, or the ECU. So again, that's the last thing on the list. Actually interesting for the EGR, this is the EGR side. We'll just have a quick look at that if I can go back up. I may not be able to now, but again, the last thing, your temp sensor circuit is open, which is very common when people remove the EGRs. And again, it comes at ECUs at the bottom of the list. So ECUs are very possibility, possibly a cause, but it wouldn't be my first pick. Now I've got another one here, which is the failsafe chart. This is limp mode. People talk about limp mode. A lot of people don't understand limp mode. Limp mode is a pre-programmed set of conditions within the ECU that allow you to get home. Okay. If you don't have an engine check light on, then chances are it's not limp mode, it's something else is wrong. There's a failure. For a true limp mode or failsafe, the check engine light has to be illuminated because that triggers the threshold for the ECU to go into the failsafe mode. Okay, and this is the list I've got of what happens when that check light is thrown for that code, when it is current. Okay, I actually think I've got one somewhere that shows, I think it's in this one, memory. And the memory is to do with if you turn the key on and off, the failsafe will be left on or off. Okay, so some of the conditions, if that code has been detected, the ECU will stay in failsafe, even if you turn the key on and off. And other ones, turning the key on and off turns failsafe off. So providing the fault isn't current, then failsafe is turned off and it'll drive like normal again. The check light may stay on, but the failsafe is turned off. Okay, so code 41. What happens when you have a current code 41? VTA, which is the idle circuit, is fixed at 0. The ECU doesn't know that the throttle is opening. So guess what? There's no acceleration enrichment. It's running solely on the fueling of the airflow meter and the temp sensor, those other things. So the TPS is no longer part of your fueling. So acceleration enrichment won't be present. It's not going to accelerate properly. Then, here's the failsafe deactivation conditions. So this one you don't even need to turn the key off. The following one or two must be repeated at least 2 times consecutively. Okay, when the idle is on, 0.2 volts is less than or equal to VTA, and which is less than or equal to 0.95 of a volt. Basically, the VTA, I would expect it to be naturally around about 0.5 of a volt at idle, at throttle switch closed. So what it's saying is it would be within that normal range of between 0.25 and 0.95. In the middle of that is close to 0.5, 0.6, and that's where the TPS should be. 1 or 2. With idle is off, VTA is between 0.25 of a volt and 4.9 volts. So the TPS spans across the range from idle or closed throttle, which I'd expect it to be around about, again, that 0.5, 0.6. And on a UZ, if you get a 3.8, you're doing 3.8 volts, you're doing really well. If it touches 4, it's amazing. Unless you got one of my enhancers, that's what makes my enhancers make a difference, because I give them more voltage and I ramp it up faster too. So for those conditions have to return before failsafe is turned off in that ECU. So that's going to stuff acceleration. Acceleration is gone if you've got a code 41. And I'm not sure this is politically correct anymore. Again, 52, 53, 55, 53 is the whole system. 52 and 55 is knock 1 and knock 2, respectively. Maximum timing retardation. I'm not sure we're allowed to say retard. It's not politically correct, but it's the correct term. The timing gets retarded to the maximum value that is allowed. There goes your acceleration, there goes your power. The engine will not perform well. Okay? So if you've got a code 41 and a knock sensor code, so a TPS and a knock sensor code, that car's not going to run properly. So we really should look at fixing those. 71, as you can see, doesn't have a failsafe. It's not going to affect the way the car runs. The EGR fault could affect the way the car runs, but throwing the code doesn't induce a failsafe. How about that? That's the better way to say it. There's a couple of bits and pieces here, and there's some really good information. And this is from Toyota. This is the Toyota stuff. I will be forwarding these on to Joshua. Yep, I will forward all that information on to you, Joshua. We're just going to get rid of this man for the moment. Right, the next thing we're going to look at, how do we fix the TPS? And what would I do? Is it this one? No, that's code 71. There's the diagnosis for that. Code 41 and 47. Sub and the main throttle position circuit. Okay. Now, processes that I would use of diagnosing this. First thing I do is clear the codes. I know what they are, I've recorded them. Clear them. Pull the main EFI fuse out. 10 seconds, put it back in. And then I would recheck the codes at that point that there are none present. Okay, so there's no codes present. I would then start the engine and go for a drive. And that's going to give me an idea if they come back. I've seen it so often. Cars have been to a garage is stuffed around, unplugged stuff, there's a check light on, then it goes to another garage who go, well, there's a problem, and spend all this time diagnosing a problem because the last garage unplugged something and induced a problem. So don't get caught out on that. Clear the fault codes, recheck it. Here's some information about the circuit, about what it does. I would normally test it with my diagnostic scan tool so I can see the throttle opening of what the ECU is seeing. You can check it with a multimeter, and I will do a video at some point specifically on checking the throttle position sensor with a multimeter. Basic tools that most guys should have ability to use if they're working on their cars. Okay, and it tells you what it's doing. You know, fuel air control and the reasons and idle speed and all those other bits and pieces. So there's some information there about it. It brings up the sub throttle position sensor because that's very similar diagnosis to the codes. Okay. We've got checking some voltages. And here's an interesting, really interesting one. If diagnostic codes 22, water temp sensor circuit, 24, air temperature control circuit, and code 41, throttle position sensor circuit, are output simultaneously, E2, sensor ground, may be open. All those have got the same earth, the throttle position sensor, the water temp sensor, and the air intake, or the air temperature circuit sensor, is on the same circuit for the earth. Output from the ECU on E2. The airflow meter is on a different earth, the airflow meter circuit. And understanding those helps with diagnosis, of course. There's the wiring diagram. Now, this one, just looking at the diagram, I'm thinking, you see that pinout is not for a 93. That is for a SC400. So having the right pinout for the ECU does help a lot when you're checking this. And look at this. Here are some voltages. Fully closed, 0.1 to 1 volt, and below 1 volt for the idle. Fully open, 3 to 5 volts. I'd expect it to be 3.8 to 4. I'm probably a bit more picky. And 10 to 14 volts for the idle switch. So you can check it at home with a multimeter by following these instructions. Pretty cool, pretty easy. There's the sub-throttle position sensor circuit, which lots of people I see don't know about setting it up, but there are some resistance readings and some checkings of that as well. And you'll see here, this is, I've got to stop putting this in here. You run through the checking, and if it's okay, and it's okay, look right at the bottom. The last thing, check and replace engine ECT ECU. So it's telling you to check the sensor. It's telling you to check the harness, check some readings, compare it against the idle switch. And if then it fails, if those tests are all okay, then the ECU has failed. Not first, last. And I get this so often. Guys talk to me, and Joshua's talked to me earlier rather than later instead of spending the money on the ECU. And hey, I recommend getting ECU serviced. Don't think that I'm not saying that. But so often I see guys who've got a problem with their car. They look on a forum. Everybody says it's the ECU. So they send the ECU away, and it's not the ECU. Yes, the ECU may have needed a service, but it was not the fault. And then they don't have the money to fix the other problems or the knowledge to fix the other problems, and they scrap the car with a perfectly good ECU in it, rebuild ECU. Or sometimes what you have, they go in this big circle of ECU problem because they haven't fixed the car, or they fix the car and then there's still an ECU fault because the ECU was not repairable, and they do this big circle of fault codes and go on a big spin, and then they scrap the car. That's really sad. Diagnose the stuff properly, and we can have better cars that last longer. So I'm going to forward that information to Joshua. And hey, Joshua, it is free of charge today, this one. You're my lucky person of the week that's getting this help, okay? Right, next one, we're looking at, what's this going to be? Oh, knock sensor circuit. Woo! Same sort of deal. Now, I have already done a video on this, so go to my channel, push the right button. I did a search for knock sensor on the channel, on my videos. Look at this, I've got LS400 knock sensors, which I think I put up there. LS400 knock sensors, look at that. I've got a picture of a knock sensor on it. And I've got the repair of the loom, rebuilding the knock sensor loom. Very good. That's already information, free information out there for guys. We've looked at that one. We're going back to this. This is going to have knock sensor circuit. Look at that. Okay. Now, this is actually some really interesting stuff. Tells you a little bit about the knock sensors. That they bring up, they detect if the engine's knocking. And guys in America are really hurting their cars at the moment. Price of fuel over there is stupid. And there's lots putting lesser fuel in, so I'm getting more guys having issues because they're pushing the limits of their engine. These are a high compression engine, and they don't like shitty fuel. I would never run them on a cheaper grade unless the other stuff was not available. So it's a high grade. Over here, we do use a different measuring system. I would put 98 or 95 or a 98 in. Again, we've gone over the thresholds or the reasons it's detected. And here's your trouble areas. A short in the wiring, a sensor, or the ECU. I see a lot. Rats climb underneath and chew the wiring. They just love chewing that wiring. I see sensors getting brittle and breaking. I also see the other one to watch is bad connections at the ECU itself. all those. So, and it's not unusual to have both knock sensors playing up. Okay, look at this. It's telling us a little bit of a picture of what's going on. They work on a frequency. And here is a test technique. Start engine and warm up. I would have thought you'd warm the engine up, but they obviously want the mechanic to warm up as well. Probably some push-ups, yep, some star jumps. Get your exercise in. Make sure you're nice and warm. After engine was, if the engine was warmed up, let it idle for 3 minutes. Turn the AC on. Perform quick racing, 5,000 RPM 3 times. Rapidly depress the accelerator pedal and suddenly release it. If the malfunction exists, the check engine light will light up when the sudden racing is performed. And then there's a notice: if the conditions in this test are not strictly followed, detection of the malfunction will not be possible. That's what Toyota recommend. Rev the shit out of it for 3 times quickly. Same deal, we've got this flow chart. Check no continuity of knock sensor circuit. So again, out with your multimeter, check your continuity in from the ECU. And guys, this works on all of them: SC 400s, LS 400s, all the non-VVTIs and the VVTIs. It will work. Okay, 3UZs, it will work. That same test can work. Test it from the ECU. Check the continuity of the circuit. Check knock sensor. If they're no good, replace the sensor. Okay. If there's continuity and it's good, we go down here. Check the continuity of the knock sensor circuit. Check for open. The sensor's okay. The circuit is okay, but we're still checking the circuit. Yeah, so Toyota's not always bang on. So check for open or short in harness and connector between the knock sensor and ECU. And if it's no good, repair or replace the harness or connector. I see it heaps. I do lots of them. Every intake I take off, I really check that sensor harness properly. And if I get worried, I just build a new one. Does the malfunction disappear with a good knock sensor installed? Yes. Replace the sensor. So we're actually suggesting there that you substitute in a known good sensor. Most guys would just put in a new sensor. And then if it doesn't go away, then check and replace the ECU. Again, ECU's on the list, but it's last. Do the testing, then ECU. There's a little wiring diagram, and that is SC400, but again, the principle is the same. Here's an inspection. Look, from the ECU to ground, and it gives a resistance of 1 megaohm or higher. So it allows you to check the knock sensor circuit from the ECU. Same deal, checking the knock sensor directly. Notice the picture? That's actually the really early knock sensor on the very first cars. They changed the plug on the later one. They kept the same picture. They didn't upgrade this. And again, it also gives a little bit on checking it with an oscilloscope, which is real cool. And it's telling you the frequency is 6.6 kilohertz. Not everyone's going to have access to that stuff. But very cool. Any garage or technician diagnosing this stuff should have even a basic oscilloscope to check that sort of stuff. I'm gonna run out here. I think that's the last page. I don't think there's any more, fortunately. So again, the last thing is the ECU, not the first. Do some tests, do some checking. Have I checked all my resources there? I think I've got another little sheet over here. EGR gas sensor, because he did have a EGR fault as well. And there's some resistance checks for checking the EGR. That's for the early one. There are different styles. I would expect his one to be vacuum operated, not the stepper motor orientated. And so there's some resistances. But it's not going to cause poor running as such, providing the EGR is functioning correctly. That's the whole nother problem. Diagnosis system, we got that one. We've discussed all those bits that I wanted to discuss. I had them pre-prepared. Righto. So I hope that's been somewhat helpful in explaining this sort of stuff. This is basic stuff. I was really fortunate that in my career, my working life, I went from a wrecking yard, pulling cars apart for a little while, into a garage with a man who was extremely good at diagnosing, to a man who was even better at diagnosing. And that was the business I now own myself. And I spent a lot of time tuning cars. I was not qualified at that point. I curtailed, I missed that step and went back later to get my qualifications. And I learned that qualifications aren't the biggest thing, but being able to think and be good at this sort of stuff. I'm a mechanic too. Zero training at auto electrical. Zero. Okay, I'm not an auto sparky. But I spend my life wiring because I've got a passion and I like doing it, and I've adapted these same techniques, and I read a lot. I look, I watch, I ask questions. Once I've established enough knowledge to work out that the answers that I'm getting are coming from someone with knowledge. So this is easy. This is basic stuff that if you're working on cars, a test light, a multimeter, some basic tools, and you can diagnose these. And we've got all the information. We've got the best information system in the world we've ever had as mankind for all these bits and pieces here. I'm going to forward these sheets to Joshua. He's going to have a read. I'm going to give him a bit of help personally. Thanks very much for saying that I could make this video, Joshua. Really helpful, and I hope it's helped a lot of other people as well. So we'll talk to you again soon. Catch you later.